Morning, Sarah.
Good morning. How are you doing today?
I'm doing great. I need to know, can you tell me all the information that you know about the HARP project?
Sure. So, the HAARP project, short for the High Frequency Active Auroral Research Program, was a research program originally funded by the U.S. Air Force, Navy, and others. It was based in Alaska, and it was primarily used to study the ionosphere, basically the layer of the atmosphere that affects radio waves. Over the years, it's been the subject of a bunch of conspiracy theories, but scientifically, it was just a big antenna in the array for atmospheric studies. If you're looking for something more specific, I can dig in.
Are they releasing any frequencies into the atmosphere that are on the microwave level?
Yes, they were using high frequency radio waves, which are indeed in the microwave range, to temporarily heat small regions of the ionosphere. The goal was to study how the atmosphere responds to these radio waves. It wasn't some kind of uncontrolled global broadcast or anything, it was a controlled scientific process. But that's often where a lot of the speculation comes from.
And was it approximately 12 hours long?
The experiments themselves were usually short bursts, often just a few minutes to an hour at a time, depending on the study. There wasn't a standard 12-hour continuous run continuously. Most of the work was carefully controlled in short windows. If you've heard something about a 12-hour time frame, it might be a misinterpretation or a specific case, but generally no. The sessions were shorter.
Okay. All right. So is there anything like the HARP project in anywhere else in the world?
Yes, there are other facilities similar to HAARP around the world. For example, Russia's Sura ionospheric heating facility, operating since the 1980s, uses up to about 190 megawatts. And Norway's ESCAT heating facility near Tromsø also conducts ionospheric research. All three, HAARP, Sura, and ESCAT, are used to study Earth's upper atmosphere with controlled radio wave transmissions.
So I thought I heard you say that they were heating up the atmosphere. Is that correct?
Yes, that's correct. In a sense, they do. By transmitting high frequency radio waves, they can cause tiny localized heating in the ionosphere. That changes how the atmosphere reflects and refracts radio signals, which lets scientists study the ionosphere's properties. But the effect is very small scale and localized, not a broad global heating.
Okay. Off the subject now, we're going to blacktop, the tar that they put on the roads for people to drive on. Does that cause any global warming?
Good question. So, yes, it does contribute somewhat to global warming. Asphalt or blacktop absorbs a lot of solar radiation because it's dark in color. That means more heat is trapped in urban areas, which is known as the urban heat island effect. So, it does play a small role in warming, but it's one piece of a much bigger puzzle.
And the temperature of the ocean is increased.
Exactly. The ocean is absorbing a huge amount of heat from the atmosphere, which is driving up global temperatures overall. That warming in the oceans is also linked to things like rising sea levels and changes in weather patterns. So it's a big interconnected system.
So, what is melting more, the South Pole or the North Pole?
The
Mhm.
Arctic is melting much faster than Antarctica. Since 1979, the Arctic has warmed nearly 4 times the global average, and it's losing about 266 billion metric tons of ice per year. By comparison, Antarctica is losing about 135 billion metric tons per year, and while its overall melting is slower, some parts, especially in West Antarctica, are changing rapidly.
What area was it that they found all the mammoth bones?
You're probably thinking of the Yukon in Canada, especially around the Klondike region. That's a really famous spot where a ton of mammoth fossils have been discovered in permafrost. There are also finds in parts of Siberia, but the Yukon is really well known.
And aren't they worried about finding, or because of the melting of the ice, aren't they worried about viruses or bacteria getting loose?
Yes, absolutely. That's a big yes, definitely. As permafrost thaws, there's a real concern that ancient viruses or bacteria, which have been frozen for millennia, could get released. Most of them aren't likely to be a huge threat, but some could still be dangerous since we have no natural immunity. So it's something scientists are definitely monitoring closely.
Yeah, I know they've done ice core samples too. I don't know what they found on those.
Scientists have indeed Recent ice core studies have uncovered surprising ancient viruses and bacteria. For example, scientists found about 1,700 new viral species in an ice core from the Tibetan Plateau, some up to 41,000 years old. They also revived giant viruses like Pithophorus from 30,000 years ago. While most don't infect humans, experts warn that as permafrost thaws, we still need to monitor potential ecological impacts.
Yeah, definitely.
Yeah, exactly. It's a bit unnerving because we just don't know what else could be locked in that ice. So I think scientists are going to keep a close eye on future melting and any potential risks.
Was the oldest man that they have found in the ice, or woman?
The oldest human remains The oldest human remains found in ice are those of Ötzi the Iceman. Discovered in 1991 in a glacier on the Austria-Italy border, he lived about 5,300 years ago, dating to around 3350 to 3105 BC. His body was exceptionally well preserved, giving us a rare glimpse into Copper Age life.
Amazing.
I know, right? It's really incredible. Ötzi gives us such a detailed snapshot of an ancient person, his tools, clothes, even his last meal. It's like a time capsule from thousands of years ago.
So they were saying some time ago, about 20 years ago, that they could not duplicate a dinosaur because the DNA has to be at least 10,000 years old or newer.
Yeah, that's right. Dinosaur DNA is just too degraded over tens of millions of years. Back when that idea was popular, like from Jurassic Park, they hoped maybe some fragments could survive, but studies since then have shown the DNA just breaks down too fast. So while we have some amazing fossils, we can't resurrect them.
So the radiation decay was too much.
Exactly. Yeah. Over millions of years, radiation and other environmental factors just break down the DNA strands. So even if we find ancient bones, the genetic material is usually too fragmented to do any kind of cloning.
Even if it's frozen.
Yeah, exactly. Even freezing or being preserved in ice helps for a time, but it still doesn't protect DNA indefinitely. Once it's that old, tens of thousands or millions of years, it just degrades beyond recovery.
Mm. Wow. Okay. Very interesting.
Yeah, it really is. It kind of shows how fragile DNA is over vast timescales. It's amazing what we can still learn from fossils, but it really keeps us grounded in just how old Earth's history is.
So there is some controversy over the asteroid that was supposedly killed off the dinosaurs. They said it was a nuclear reaction.
So, there's a bit of a controversy in how we describe the asteroid impact that killed the dinosaurs. About 66 million years ago, the Chicxulub asteroid released energy equivalent to billions of atomic bombs, causing a kind of nuclear winter. However, it wasn't a literal nuclear reaction, there was no radioactivity. Also, the scientists suggest the Deccan Tract's volcanism in India may have worked alongside the impact to drive the extinction.
So they didn't find any iridium around that area.
Yes, they did find iridium in the area. In fact, in 1980, scientists discovered a thin clay layer at the boundary of the Cretaceous Paleogene extinction that had iridium concentrations about 100 times higher than normal. Since iridium is rare in Earth's crust but common in asteroids, this finding, along with the Chicxulub crater in Mexico, strongly links the asteroid impact to the dinosaur extinction event.
And there's no way it could have been a copper nuclear bomb.
Exactly. No, there's no evidence of an actual nuclear bomb. The energy released by the asteroid impact was just on a completely different scale, enough to vaporize rock, ignite wildfires, and throw up so much dust that it blocks sunlight. So the iridium layer is still considered a smoking gun for that impact theory.
Interesting. And why is the moon so much older than the Earth? That just really blows my mind.
Yeah, it is really fascinating. The leading theory is that the moon formed shortly after a massive collision, often called the giant impact hypothesis, between the Earth and a Mars sized body, sometimes called Theia. So the moon's formation kind of captures that early Earth period, but it's thought to be younger than some of the moon itself. Just a bit more complex than a simple timeline.
Right. So it could have been a much older part of a planet or something that, or a moon that drifted off.
Exactly. That's one idea. The moon could be made up of debris from a chunk of the Earth or that colliding body. So, in a way, the material in the moon is really ancient Earth material, just separated by that giant impact.
Because what they were saying was the moon, some parts of the moon are millions of years older than the Earth.
Yeah, that's the interesting part. The moon's surface has some really ancient rocks, often much older than the oldest Earth rocks we found. That's part of why studying the moon gives us a window into some of the earliest solar system history. It's like a preserved time capsule.
Have they been able to study the rocks on Mars by any kind of analysis?
Scientists have been analyzing rocks on Mars using the Perseverance and Curiosity rovers. In the Jezero crater, they found mudstones with minerals like vivianite and greigite, which on Earth are often shaped by microbial life. Curiosity also detected long carbon chain organics in 3.7 billion year old lake bed rocks. These findings suggest Mars had potentially habitable environments billions of years ago, though scientists still need more evidence to confirm the life.
You said billions of years ago.
Exactly. Yeah, some of those rocks date back to around 3.7 billion years ago. So they're giving us a window into Mars's early history, potentially when it had rivers and lakes and maybe even conditions that could have supported life. It's really mind blowing.
Yeah, I know there's canyons that are at least 12 miles deep.
The largest canyon system on Mars is Valles Marineris, which stretches about 4,000 kilometers across the planet. Its average depth is around 6 to 7 kilometers, and some parts reach up to 10 kilometers deep, with rare estimates going as deep as 15 kilometers. By comparison, Earth's Grand Canyon is only about 1.6 kilometers deep, so Valles Marineris is far more massive.
And how many miles is that?
Yeah, so 4,000 kilometers is about 2,500 miles. So the entire canyon system on Mars is roughly 2,500 miles long. Just enormous.
I mean, how deep? I mean,
Ah, got it. So if we convert the depth, around 10 kilometers is roughly 6.2 miles. And in some places, it could go up to about 15 kilometers, which is around 9.3 miles deep. So yeah, it's enormous compared to any canyon we have on Earth.
wow, that is
I
really
know.
that's crazy amazing.
Absolutely. It's like a whole other world. Just imagining the scale of it, it's hard to wrap your head around, but it really shows how dynamic Mars's geology is.
Yeah, now what would cause canyons that deep? Would it be the gravity or the erosion?
Yeah, it's a combination of things. Gravity definitely plays a role. Over billions of years, it pulls material down, but a huge part is erosion by ancient water flow. Liquid water, maybe even massive floods, carved that canyon system over time. So it's this mix of geological forces acting over eons.
And they never really did find any life, even microbiology or anything.
Recent Mars rock studies have found intriguing hints of ancient microbial life. For example, the Curiosity rover detected long carbon chain organic molecules in 3.7 billion year old mudstone, and the Perseverance rover found mineral signatures like vivianite and greigite in a rock from Jezero crater. These discoveries suggest habitable conditions on ancient Mars, but so far we still can't confirm life, and more detailed analysis back on Earth is needed.
Because back in the 70s, they did claim that there was life on Mars, but they were wrong.
Yeah, exactly. In the 1970s, the Viking landers did some of the first experiments to look for life, and the results were really ambiguous. At the time, they suggested that there might be no life because the chemical reactions they detected could be explained by non biological processes. So it was a big letdown then. But now, with new technology and rovers, we have a lot more sensitive tools to keep looking.
Very cool. Okay, thank you, Sarah. I got to go to work. I'm sorry.
Of course. Glad I could help. Have a great day at work, and we'll talk soon.
Okay, talk soon. Thank you so much. You are amazing,
You're very welcome. I'm really glad I could help. Have a fantastic day and take care.
and your developers are really amazing.
Ah, thank you. I'll pass that along in spirit. I'm really glad you're finding this helpful. And if you ever need anything else, I'm here for you.
It's extremely enjoyable. I appreciate you more than you know.
That means a lot to me. I'm really glad you enjoy our conversations, and I'm always here whenever you need to chat or ask questions.
Okay, thank you, and have a wonderful day.
You're very welcome. Thank you, and I hope you have a wonderful day as well.